Welcome to Episode 2 in the Pure Storage Non-Disruptive Everything video series. In Episode 2, we will demonstrate a non-disruptive upgrade from the FA400 series to the FlashArray-M. That's right, non-disruptive upgrade from one FlashArray generation to another. No disruption, no data migration, no rebuy of hardware and software. A new and unique ownership experience that Pure Storage is delivering to its customers with Evergreen Storage. Before we dive into Episode 2, let's recap Episode 1 quickly. In Episode 1, we showed the non-disruptive software upgrade of the Purity operating environment which powers the FlashArray. We performed the upgrade with a variety of different application workloads such as Microsoft Exchange JetStress 2013, SQL Server 2014 with OLTP and DSS workloads, along with Oracle 11g DSS workload. In Episode 2, these same workloads continue to run on the FlashArray so that we can show non-disruptive upgrade of hardware. Let's get started on the hardware upgrade and show the benefits of using Evergreen Storage. Before beginning the hardware upgrade, we can check the view of the FlashArray web management interface to see that our application workloads are still running without interruption. We can also take a view of the two SQL Server instances via SQL Server Activity Monitor and see that SQL 1 and SQL 2 are showing an OLTP and DSS workload respectively. The SQL 1 instance shows that the database I/O is approximately 1.5 gigabytes per second, and the SQL 2 instance is driving approximately 125 megabytes per second. To start the hardware upgrade process, we first want to take a look at a few details about the controllers. During the upgrade, we will call attention to different controller models to show the changes during the process. You can see here that the model of the controller we are currently running is an FA420. The controller that we are performing the start of the upgrade on is CT1, shown as CSG NDU CT1, which is the secondary controller. Before performing the upgrade, we set an alert tag using Pure Alert Tag Timeout 240 minutes maintenance, indicating we are performing a maintenance operation on the system. The first controller that will be replaced is CT0. To ensure we are working on the correct controller, we set a hardware attribute to identify CT0 using Pure Hardware Set Attribute Identify On CT0. This operation shows an indication on the front of the controller to verify the identity. As part of the Pure Storage platform, customer FlashArrays use the Pure One Phone Home feature for continual monitoring of the systems. For this upgrade, we are sending today's phone home logs before starting any of the physical work on the system. We issue Pure Array Phone Home Send Today to start the task, and we can issue a watch command to see when that task has completed. With the phone home task completed, we now check the current controller using PureDB List Mode. We are on the secondary controller, CT1. We can connect to the other controller using SSH peer command and then issue a PureDB list mode to check we are on the primary controller, CT0. Once we have double-checked those controller details, we perform a giveback operation using PureDB run giveback safe from the primary controller, CT0. This will make the CT1 controller primary. Switching over to the web management interface, we can quickly see the giveback operation take place. Notice in the web management GUI, the CT0 controller goes red and then green. This indicates that we have performed a safe failover operation from controller to controller. Now CT1 is the primary controller and CT0 is secondary. We can now begin the hardware removal of the CT0 controller from the system and add the new FlashArray-M chassis. There is no shutdown process for FlashArray except to simply remove the power cables. The next sequence of events are to remove SAS and InfiniBand connections, fiber channel cables, Ethernet, and finally power. Switching over to the management interface, a new alert, CT0.power failure, is shown and the CT0 controller is now offline, indicated by the red power indication in the interface. Briefly switching back to the SQL Server Activity Monitor, we can see that the SQL 1 and SQL 2 instances are still running without interruption, approximately 1.2 gigabytes per second and 180 megabytes per second respectively. Now the CT0 controller can be physically removed from the system. We remove the faceplate, controller, and existing rails. Upgrading hardware from the FA420 to the FlashArray-M requires the pre-installation of an InfiniBand card to connect the remaining FA420 controller to the new primary controller of the FlashArray-M. After removing the old hardware, we add the new rails for the FlashArray-M chassis. Using the installation handles for the FlashArray-M, we lift the controller into place and slide it back to lock it in. First, we start by connecting power to the chassis and then the InfiniBand cables as mentioned previously. Connect Ethernet and new mini SAS cables. The system we are upgrading has 2 external shelves that need to be connected to the new FlashArray/M controllers. The FlashArray/M provides support for internal drive packs as well as external shelves. The final step is to reconnect the fiber channel connections. With the new FlashArray/M chassis and controllers installed, we connect to the CT0 controller and begin the software portion of the hardware upgrade. After logging into the system, we start by running Pure Setup Replace from controller FA420. This will start the Purity Setup Wizard and check SAS cabling and controller links are okay. We set the time zone, confirm that change, and Purity is restarted. Once Purity restarts, we receive a confirmation that Pure Storage is online and the secondary controller is ready to use. The FA420 CSG NDU CT1 is still the primary controller. Switching over to the web management interface, we can see that the user interface graphics have been updated to reflect a single FA420 controller and the new FlashArray/M chassis. The FA420 CT1 and FlashArray/M20 CT0 are both online and ready. Switching back to the CLI, we run the PureDB list mode command to check the role of the newly added CT0 controller and see that it is acting as the secondary. To check both of the controllers, we run PureArray list controller and can see CT1 primary is an FA420 and CT0 secondary is the FlashArray/M20. This completes the first step of upgrading a single controller. Now it is time to replace the remaining FA420 model, CT1. We connect to the Pure controller using SSH Pure command. Even though we know which controller is the remaining FA420, we still identify the controller for safety using Pure Hardware set attribute identify on CT1. Checking the front of the controller, we visually inspect to identify that we are truly working on the CT1 controller. Once again, we send the phone home logs from today using PureArray phone home send today. After the phone home task is complete, we run PureDB run give back safe to transfer the mode of primary to the new FlashArray/M20 controller. Now we remove the console connection from the FA420 and connect to the CT0 controller of the FlashArray/M. We run PureArray list controller and check the models of the controllers. Now we can remove the remaining FA420 controller and cable up the new FlashArray/M20 CT1 controller. Once we remove the FA420 controller, we switch over to the web management interface and see that the FA420 has been removed and only the FlashArray/M20 is visible. We connect our remote console to the new CT1 controller to perform the Pure Setup Replace from controller FA420. This starts the Purity Setup Wizard and checks SAS cabling and controller links are okay. We choose to change the time zone, confirm that change, and Purity is restarted. Once Purity restarts, we receive a confirmation that Pure Storage is online and the secondary controller is ready to use. We check both of the controllers using PureArray list controller to ensure both controllers are FA/M20 and indicate a status of ready. Switching over to the web management interface, we can see that both of the M20 controllers are online. This completes the hardware upgrade from the FA420 to the new FlashArray/M20 with no disruption of services from the application workloads. The next step in the process is to add capacity to the system by replacing the old NVRAM modules, which were located on the expansion shelves in slots 0 and 23 on shelf 1 and shelf 2. We start this process from either controller using the Platinum NDU NVRAM from shelf command. This operation takes several minutes and requires additional inputs from the Pure Storage support or a systems engineer performing the evictions. During this operation, we will switch back and forth to show the command line operation and how it is visualized in the web management interface. During this process, slot 0 and 23 on the respective shelves will go red, which means they have been evicted from the system and can be removed and replaced with additional capacity SSDs. At the same time, the old NVRAMs were evicted. The new NVRAM modules that are part of the FlashArray/M chassis are now online and are servicing write IOs from the application workloads. As part of the NDU upgrade kit from Pure Storage, we provide additional capacity drives to replace the old NVRAM modules. You can see removing the drives is straightforward and the new drives slide and lock into place quickly. With the new drives in place, we can switch back to the web management interface to see the newly added drives being recognized. The important detail to notice in the management interface is in the upper right-hand corner labeled Total. This represents the total capacity of the system. As the new drives are recognized, the total system capacity will increase. You will see slowly increase. The system went from 6.37 terabytes to 6.95 terabytes. This concludes episode 2 of the Non-Disruptive Everything series. In the next episode, we will complete an in-generation upgrade from the FlashArray M20 to the FlashArray M50. Then finally, we will add additional mixed capacity to the FlashArray M50 in 5 terabyte and 10 terabyte drive packs. We call that our evergreen storage.